Recall from the first law of thermodynamics that your internal energy, du, is equal to dq, or your change in heat, and dw. And alam din natin na yung dw is equivalent to minus p external dv. Now, we can substitute that expression again doon sa du. So, yung du natin magiging equal siya sa dq minus p external dv. Okay. What if we have a case for a reversible process? Okay. And remember, for a reversible process, we can obtain the maximum work na pwede. So kapag reversible yung process natin, yung du magiging du rev, yung dq magiging dq reversible, and then minus pdv, because for a reversible process, yung pressure ng gas, for example, is equivalent almost to the pressure external. Now, doon sa second law of thermodynamics, na-define natin how to calculate or what's the mathematical expression for the change in entropy. So remember, ds, or change in entropy, is equal to dq rev divided by t. Alright? So, ibig sabihin, itong expression na to, pwede nating i-combine dito sa previous equation. So, let's do that. Yung du rev natin, magiging du pa rin siya. Remember, internal energy is a state function, right? So, whether it's reversible or irreversible, wala tayong problema. So, du equals, yung dq rev natin, we can now express that as T times the change in entropy minus P dV. So now you have this expression, and lo and behold, this is what is known as the fundamental theorem of thermodynamics. This is a beautiful equation. It's one of my favorites kasi this equation, this theorem, it captures both the beauty and the principles of both the first law and the second law of thermodynamics. So yan yung fundamental theorem of thermodynamics. Now, anong application ng equation na ito? So, if you look at the equation, okay, du equals TdS minus PdV. So, gaya ng sinabi ko, pinagsama na dyan ang first law at second law of thermodynamics. Now, the equation, it looks like it suggests that si internal energy is actually a function of entropy at saka ni volume. Paano ko yun nasabi? Kasi sila yung differential, si S tsaka si V, sila yung variable, sila yung pwede nating ma-vary doon sa equation na yan. So, ang ibig lang sabihin yan, the fundamental theorem of thermodynamics suggests that internal energy is a function of entropy and volume, and this is natural. Okay, natural lang daw na nagva-vary yung internal energy according to changes in entropy and volume. Now, if that's the case, if we are going to get the total differential of internal energy du, gaya ng alam na natin gawin, so that will be, di ba, ang gagawin natin is get the partial derivative of u with respect to the first variable, making the second variable constant, ds, plus partial derivative of u with respect to v this time. Tapos, yung first variable s is constant, and then dv. Alam na natin gawin to, right? Now, since we have this total derivative, i-compare natin yan ngayon dito sa fundamental theorem of thermodynamics. Ang nangyayari ngayon is that yung parehong equation na yan, may differential s, right? So may differential s dito, may differential s dito. May dv, mayroon ding dv. So it looks like if we're going to compare these two equations, this factor here is equivalent to temperature here, and this factor here is also equivalent to this pressure na nakasulat doon sa equation. So let's write that down. Ang ginawa natin is we were able to kind of prove, right, that the partial derivative of u, or the change in internal energy with respect to s at constant v is just equal to t. And the partial derivative of u daw with respect to v at constant s is equal to negative p according to the above equation. Okay, ang maganda dyan is we were able to obtain two additional equations, right? One is this one, and another is itong isa. Okay? Now, ang problema nga lang, alright, let's say that you want to get the change in internal energy. Okay? Now, walang problema dito sa second equation. Kasi, if you want to determine daw the change in internal energy with respect to V, that's just equivalent to negative P, right? So, ang constant dyan si entropy. Ang tawag natin doon is isentropic na process, if you will. Okay? So, madali lang naman i-control yung V. Volume naman yan, right? Okay, so no problem with that. But if you are going to take a look at the first equation, change in internal energy with respect to S, the variable here is si S. Okay, siya yung i-vary daw. But remember, S is entropy. And S, okay, it's not controllable. Not controllable. Ibig sabihin, let's say, gusto mong i-calculate yung paano nag-change yung internal energy, right? So, ang gagawin natin ba ganito? Okay, calculate natin yung internal energy change at constant volume. Ang gawin natin pare, ibahin natin yung entropy. I-vary natin. Pwede bang gawin yon? Can you really vary entropy? It's really difficult to do. Even I don't know how to do that, right? Good luck with that. I mean, entropy is not controllable. There is no such thing as an entropy meter. So, entropy is not measurable. So, hindi natin siya pwedeng i-vary. Unlike yung temperature, pressure, and volume, we can do that. So, anong gagawin natin ngayon? Thus, we have now a mathematical problem. What do I mean? So, if you're given, and in this case, given that yung internal energy natin is a function of entropy and volume, however, entropy nga cannot be varied, it's not controllable. So, given that, we want to find the function. So, find a function f, okay, such that this function f is a function of the following. Number 1, partial derivative of u with respect to s at constant v. And number 2, and the other variable here, f, is a function of yung volume. Okay? Remember again, this derivative here is equivalent to temperature, right? Temperature yan according to our derivation kanina, which is here, the first equation. It's just that gusto nating maghanap ng bagong function f such that hindi si s yung i-vary natin, but rather this derivative. Okay? Kasi ang gusto natin mangyari is we want to find a function that contains the information inside this derivative. And that derivative, remember, it has an information on entropy. Okay? So, kino-convert natin ngayon yung original function natin sa isang bagong function kung saan yung derivative, which is just equivalent to temperature, yung iba-vary natin at hindi si entropy. Kasi nga, mahirap baguhin si entropy. Okay? So, this function should be equivalent to yung ating internal energy as a function of S and V. So, let's probably discuss this in graphical way, no? So, let's say meron tayong coordinate axis dito. Alright? And meron ka, halimbawang, isang function. Okay? Meron kang curve. Now, this curve, papangalanan natin siyang y of x. Okay? So, meron kang x. Yung y-axis mo is definitely y of x. Right? Now, you wanna determine the slope, okay, at a certain point x. So, meron kang x dito. Okay? So, you can call it x1, x2, x3, whatever, basta x yan. Now, at that point, at that value of x, meron kang point dito. So, meron kang corresponding y of x, of course. Ang mangyayari dyan is, if you wanna determine the slope at that point, and let's try to sketch that slope. Diba pag sinabi nating slope, tangent siya dun sa curve. Okay, so yan yung slope. Okay, so yung slope na yan, let's denote it bilang, usually in math, we use m for slope. This time, let's use t. Slope t. Right? So t, paano ba gamitin or paano ba kunin ang slope ng isang function? Diba? It's just the derivative of that function. So, the derivative of y of x is dy over dx, right? So, that's the slope. At that particular point x lang. Okay? So, if you will vary the value of x, kunyari, yan, x1. So, limbawa, meron kang another value of x, x2, for example. So, at this point, meron kang x2. So, nasan yung point na yan dun sa curve? Nandito siya, right? So, if you wanna draw the slope, okay, it will look something like this. So, tangent siya dun sa curve. Okay, yung kanina, tangent din siya dun sa curve. And let's just probably draw it all the way. Okay? So, what did you notice? Notice na si y-intercept and si y-intercept sabihin nating, okay, let me probably draw another line here. Oops, should be white. Ayan. Now, yung dalawang slope line natin, ituloy-tuloy lang natin all the way, no? Para mapakita ko yung y-intercept. Ayun. And yung blue line naman, ayun siya. Okay. Now, take a look at the y-intercepts. Okay. So, itong y-intercept natin, tawagin natin siyang y, or rather, f of t. Okay, bakit f of t? Bakit function yung y-intercept? Kasi if you notice, if you change x, let me just write that down, no? If you change the value of x, the slope will also change. Hindi constant si slope for this particular example. And if slope changes, the y-intercept also changes. Tama? Now, let's try to find an expression for the y-intercept f of t. Okay, so imagine marami kang slope depende sa value ni x. x1, x2, x3, nag-iiba ng slope, nag-iiba ng y-intercept. Pero kahit nag-iiba si slope and y-intercept, well, they still fit our slope-intercept form of our linear equation. And of course, this is only applicable for lines or curve na linear yung kanyang geometry. Remember, di ba, ang ating slope-intercept form is y equals mx plus b. So, in this particular illustration, y is our y of x, which is our function. Mx, ano ba yung m natin or the slope? tinawag na siyang t, right? X plus b. And our b is variable, so yun yung f of t natin. So if you wanna get f of t, you will get f of t equals y of x minus tx. Okay? So yan yung description ng transformation natin. So let me illustrate this further, no? Let me kind of summarize what's happening here para mas madaling intindihin. So you have a curve, a function, okay? Specified kanina by what? By the coordinates x and y of x, right? Ang gagawin natin is we are trying to transform this function to a certain new representation. Okay, representation, bago. Such that yung coordinates natin this time naging slope tsaka y-intercept. Okay, t and f of t. And remember, t will change because x also changes. So this mathematical transformation is now what we call as Legendre transform. Okay, Legendre transform. And this particular mathematical transformation is very applicable in many branches of physics, such as quantum mechanics, and in our subject, thermodynamics, magagamit natin yan. However, you have to remember that for this particular mathematical transformation called Legendre transform to be applicable, you have to assume or tinitreat natin yung derivative, okay, ni y, okay, or yung dy dx natin. Dy dx will change, right? So, ibig sabihin, function siya ng x. We are assuming that it's a monotonic function of x. Ang ibig sabihin lang niyan is that yung second derivative mo dapat should be greater than 0 everywhere. Or less than 0 everywhere. Okay? Isa lang dapat. Either greater than 0 or less than 0. If it's greater than 0, ang ibig sabihin lang niyan is that the function is a convex function or the curve is a convex curve. And kapag less than 0 everywhere, ang ibig sabihin nun, concave naman yung ating function. Alright? Now, yes, we know now how to perform Legendre transform at least geometrically. Ano ngayon? Ano yung gambit nito sa thermodynamics? So, balikan natin yung kaninang problema natin. Diba? Yung meron tayong internal energy as a function of entropy and volume, right? And remember that entropy cannot be controlled, so kaya tayo nagpe-perform ng Legendre transform para magkaroon tayo ng bagong function such that iba na yung representation natin. Okay, number 1. We want to find a Legendre transform of the internal energy function as a function of S and V. Now this time, F. So, i-convert natin yan. Transform natin to sa F. Now, F this time is yung S, papalitan natin ng temperature. Pero yung second variable volume, as is siya. Wala tayong gagawin sa second variable. So, question, bakit ko pinalitan yung entropy ng T? Kasi, di ba, yun yung ating usapan. Yung entropy na yan, okay, ang gagawin natin is this, right? Entropy cannot be controlled, pero the derivative of internal energy as a function of entropy with respect to volume is T. Okay? So, instead of S, gawin natin siyang T. So, how do we do that? Okay. So, to get this new function, okay, let me erase the equal sign. F as a function of T and V. Well, ang gagawin mo lang naman is sundan mo lang yung ating equation kanina for Legendre transform. So, all you have to do is get F of T, and that's equal to the function y of x minus the slope times the x or the independent variable. So let's do that for internal energy. So F as a function of T and V, Okay? So yan yung f of t. Now, what is y of x? Y of x is the original function. And that's basically just your internal energy, right? Minus the slope t. Ano ba yung slope? Yung slope is basically yung derivative na ito. And that derivative, nagkataon, equal siya sa temperature. So, ilagay natin to t. And then times x. Ano yung x? That's just the independent variable. And the independent variable here is yung kung ano yung variable na binavary nung unang form ng function, which is your entropy. So this, right? That's the independent variable. So now we have the expression u minus ts. Okay? So gawin ulit natin yan. Number 2. We wanna find a new function, pero this time, hindi natin gagalawin si S, ang gagalawin natin si volume. Okay? Si volume ang gagalawin natin this time. But that variation in volume, okay, is equivalent to pressure. So, P ang ilalagay ko doon. Okay? So, F as a function of S and P now. Okay? Sundan pa rin natin yung formula. Ano ba yung function natin y of x? That's still the internal energy. Minus the slope. Ano ba yung slope? Pag binari natin yung pressure, edi yung derivative kanina na nakasulat doon, partial of u with respect to v at constant s, and that's equal to what? Negative p. Okay, so minus of minus p times volume. Okay? And that's equal to, kapag sinimplify natin to, u plus pv. And lastly, paano kapag both variables ang binago natin? Okay? Instead of S and V, gawin nating T and P. Temperature and pressure. So, still, you will use the same formula. Y of X is just your internal energy minus, okay, ito, dalawa na to. Kasi, dalawa yung binary natin. So, isa-isayin natin, no? Yung una is yung slope is temperature and the independent variable is entropy. Plus, yung next, yung slope is negative P, tapos yung independent variable natin is V. Okay? So, ang lalabas dito, if you're going to simplify, that will become U minus TS plus PV. In other words, from internal energy as a function of entropy and volume, we were able, through Legendre transform, develop 3 additional equations. So, isa-isayin natin ulit. Balikan natin. Yung unang equation, which is U minus TS, bibigyan natin siya ng pangalan, and let's call it letter A. And this equation now, A equals U minus TS, ang tawag dyan sa thermodynamics is Helmholtz function. Okay? I hope I got the spelling right. Or Helmholtz free energy. Next, yung pangalawang ginawa natin, U plus PV, well, dapat at this point, alam nyo na kung ano yung expression na yun kasi we were able to introduce that in the beginning pa lang, noong pa lang first law of thermodynamics. So if you recall, U plus PV is just simply your enthalpy. Okay? So that's your enthalpy. Okay? And lastly, yung pangatlo, yung U minus TS plus PV. Let's represent the whole thing by the letter G. And I'm sure may idea na kayo kung anong equation to. So this equation now is what we call, this is the definition, mathematical, of your Gibbs free energy. So, collectively, si internal energy, si Helmholtz free energy, si enthalpy, tsaka si Gibbs free energy, we call all of this na thermodynamic potentials.